Over to you then, Ian, please.
Thank you very much, Stuart. So welcome everybody, and thank you for joining us today under the Water Loss Specialist Group's webinar series. Thank you to Gary and Stuart for arranging and facilitating these sessions. So today, myself and my colleague Pepe, we're going to go through how digitalization is driving operational decision making. So we're going to look at the challenges that utilities and operators are facing, and then the solutions that they're looking for, and then together with Xylem and Idrica, the solution that we have today to help understand the inefficiencies and how we can make those operational improvements. So my name is Ian Rodgers. I work for Xylem, and I'm the Client Solutions Architect for Middle East, Turkey, and Africa. And with me is Pepe Chambo from Idrica. Actually, he's the same. He now has the same position as me. So what we do is we look at the inquiries from utilities and operators and try and understand the best solution that we can offer to help solve the operational problems that the utilities and operators are having. So we'll do this in five parts. So the first part is I will give an introduction to the challenges that the utilities are facing today, and an overview of what the solution needs to be able to deliver and how it works. Then I'm going to hand over to Pepe, who will go through some case studies, and with a fair wind, he'll also give a live demonstration of the software. And as always, we'll allow 10 to 15 minutes at the end for question and answers. So anytime anybody has a question, do feel free to put it in the chat function, and I'll open that up at the end, and Pepe and I will do our best to go through and answer those questions for you. So let's start off by looking at the introduction. So these figures came out by the IWA. I think it was towards the end of last year, and they did a lot of hard work here on trying to understand the global impact that non-revenue water and the real losses is having on greenhouse gas emissions. So it's estimated that the volume of water, of non-revenue water, is about 126 billion meters cubed across the whole globe per year. And that equates to a financial value of about $39 billion. So that would actually provide a lot of money for investment in manpower, equipment, and solutions if we could reduce that non-revenue water. So that 126 billion meters cubed of water equates to an equivalent value of about 187 million metric tons of carbon dioxide that's produced, which overall is about 0.6% of the CO2 global emissions. Now, that may not sound like a large percentage, but aviation accounts for 1.9% and shipping of 1.7%. Now, we've all seen in the press the activists who are saying, we shouldn't be flying, it's causing a lot of emissions. Well, CO2 from non-revenue water is a third of that aviation. So if we shouldn't be flying, then we most definitely should be taking real serious efforts to reduce non-revenue water. And to put that into context, a lot of people talk about carbon emission offsetting, planting trees to offset the carbon. So to compensate for the amount of CO2 emissions from real losses, it's been estimated that 218 hectares of trees needs to be planted. And that equates to the quarter of the land size of Brazil. So quite clearly, planting trees is not the way to solve CO2 emissions just by offsetting. Utilities need to make serious, strenuous efforts to reduce their non-revenue water. And we need to thank Roland Limburger and Alan Wyatt for all the hard work and putting these data out there. So what are the utility operation and maintenance challenges, the conundrums? What are they trying to solve? So first of all, do they work on transmission or distribution mains? Non-revenue water historically has been the domain of distribution, but we shouldn't forget transmission, because if they fail, then nobody has water. For your pipes, do you leave them alone and just react when there's an issue? Do you identify where you need to repair or replace? Everybody has non-revenue water, but you want to send the right team with the right tools. So you want to send the leak detection teams to areas where you have real losses, the leakage. You want to send the metering teams over where you have apparent losses. If you are going to do leak detection, where do you start? You don't want to pin the tail on the donkey and randomly pick an area of the network to start. You need to know where you have real losses, target those areas first. Ultimately, every customer meters need to be replaced. Some of them need to be replaced earlier than planned, but the question is which ones? Let's only change the ones that do need to be replaced. Let's leave the ones that are still working to keep working. When we're changing the meters, do we stick to the more traditional mechanical meters, which have a lower capex, but they don't record as accurately? They have a much higher starting flow rate. Or do you move to smart meters, where they have a higher initial capex, but over time they are more efficient, they generate greater revenue because they're more accurate, and they last for longer. And also, where you have pumping stations and pressure reducing valves and large customers, are there transients, water hammer events being generated? Are we stressing the network? Are we shortening the life of the pipes? If so, where? With that information from above, we can help better plan our CapEx and OpEx, so we can actually ask for what we need. Then the managers, the finance are more aligned with what we're doing. So ultimately, what we want to know is, how do we make those informed engineering decisions? Because what we need to know is, where are the problems? What is the problem and what do I need to do? So we can send the right team with the right tools. And when do we need to do it? We need to put a timeline. We need to identify the key issues, the critical issues. Which ones do we need to solve first? Now, most utilities have SCADA systems, they'll have flow meters, pressure sensors, but they're all separate systems. They're not integrated. So the data is there predominantly. But what's lacking is a way of integrating all that data into one platform, so that a utility can log into one platform and see how all of their assets are working. If you can do that, you have a better understanding of how your system's working. It means you can identify where you have the problems, helps to identify what that problem is and that magnitude. So continuing that old way of having separate, non-integrated solutions just isn't going to work. We need to be more efficient, more integrated, to have one platform that allows you to see everything about your assets. But that solution needs to be agnostic. It must be able to take data from any source, any provider. It cannot be limited to certain providers. It must be modular, so we can turn on and off different modules as we want to do it. So if we want to look at how our customer meters are working, perhaps we want to do digital twins or real-time digital twins. It must be interoperable. It must be able to work with other platforms, other SCADA platforms, GISs, etc. If it can be open source, it means it's much easier to integrate with existing data and new data as it comes in. Also needs to be scalable. Quite often utilities will start on a smaller scale, and if that project is successful, then it's rolled out over a larger area. So we want to be more efficient with the costs by being able to do it on a progressively increasing size. And because we're using data that's often being generated, stored on the cloud, we need a secure solution. You're going to have remote logins, so we need very good cyber-safe encryption. It also needs to be adaptable. You as a client need to tell us what you need, so we need to be able to adapt the software to best match your needs, and not just a software provider saying, take it or leave it. So what we need to do is be able to have a system that does three things, therefore: to be able to visualize the network and its assets. Where are they geo-referenced, geo-located? How are they working? Where are the problems? By analyzing that system-wide data. And if we understand how the assets are performing, we understand, therefore, the assets that are not working to the predicted level, so we can help optimize, we can help increase the performance of the networks. So what we've done, Xylem with Idrica, we've teamed up and we're now working very much hand in hand together on the utilization and deployment of their platform called Go Agua. So this is a platform that's been built by utilities. Idrica is part of the global Omnium group, that global water network and plant operator. So it's been designed by effectively a utility to help them solve their problems. So it really has been designed around solving those problems that really do exist and understood by the operators. And it does that through 6 different levels. So we have that physical asset sensing. So you've got all that different data. Then you bring all that data together into an integrated single source platform. With that, you can then visualize how your assets are performing. You can do your graphs, your charts, your reports. Because you have volumes of supply, consumptions, pressures, levels, etc., you can analyze. You can analyze how your assets are performing to give a level of performance, a level of efficiency, and therefore identifying where you need to spend time and effort and what you need to do. With that, you can then optimize because you know how your assets are performing. You can maybe make changes to your pump settings, your PRV settings. If there's different energy tariffs, can you do more pumping at night? You understand how your assets are performing. You understand what the demands are. You can better optimize. Once you've done that, you can move into more operational intelligence, where you're doing this in real time. So you're making changes to your networks and treatment plants, optimizations in real time, rather than reactive or keeping everything at normal standard set points. So again, that's just a more, so what we have here is the physical assets is the sensing, all of that platform and data goes into the smart water engine. And then we have the modules. You know, I mentioned earlier that you need different capabilities maybe at different times. So we have multiple modules to help you, the utilities and operators, better understand, you know, how your assets are working in a network, from a metering and from a treatment point of view. And that gives you all of that through the operations center. So you have all your operators, single logins, where you can see exactly how the assets are working. You may have different plants, different networks, all done through one common platform with a single login. And the main way we can help that is we've got that unified network management, which is your, you know, understanding your water balances. We can help then also optimize your treatment plants, because obviously there you've got a lot of power, a lot of chemicals being utilized. When you come to your distribution systems, you want to be able to do your DMA water balances, but also be able to identify where you've got those issues with leaks and the pressure losses. As I said before, you know, customer meters, all of them eventually, especially mechanical, degrade over time. So which ones need to be changed? Where are the meter readers not actually reading the meters? Where do you have consecutive zeros? Where the meter's gone backwards? So maybe the customers are fiddling with their systems. And then ultimately that optimization through the real time, playing around with different what if scenarios, what is the best way forward, but also monitoring your assets in real time to predict what's going to happen based upon what's happening today. So if you see a pump has gone out, how much time will that tank be able to feed the customers? So how long do you have time to fix the issue? When do you need to inform the customers? When do you need to do other network considerations? And of course, you've got to do that with very controlled. You can't allow anybody to do whatever they want with the system. Then data gets moved around, gets put in the wrong place, and all the calculations go wrong. And then you start looking for you getting bad information out of it. So you have the hierarchy administration, you have the users, but really important, you have the GIS. You know, people can't change boundaries of say DMAs or DMZs just because of something they want to do. It needs to be very tightly administered. So you get out the results that you need to make those informed engineering decisions. And to do that, you get your operational dashboards. So you get your graphs, your charts, tables, pictures of where the assets are, the dashboards for the reporting, so you can see the trends, the changes over time, and also the operational intelligence, you know, how you can be better, more organized, more efficient with your system. And so with that, I will now hand over to Pepe, who will go through some case studies. So Pepe, just let me know when you want me to change the slides.
Yeah, please go ahead. Yeah, well, first of all, Ian, many thanks for the introduction. I would like to share with you today our experience, you know, walking down this digital transformation journey, you know, our experience, the troubles that we found, and how we solve all these problems that, you know, we had to tackle with during this digital transformation journey. So as you was saying, Ian, Xylem Vue powered by Go Agua, it's a software solution for utilities by utilities. So this is the the biggest differentiator, because at the end we are solving the pains of the water utilities, because we are suffering the same pains. So everything starts at the beginning of 2020 when Global Omnium, that right now or in that time was managing or was one of the top utilities managing the east coast of Spain. And here we have several water scarcity problems, and that it's directly matched with non-revenue water. In that time, we were facing almost 50% of non-revenue water. So you can imagine in a region with several water scarcity problems, we cannot work with this 50% of non-revenue water. And also our operational cost, the cost that we have, maintaining our operation was too high, and we cannot work in that way. So we started to do some changes. In that time, the market talked about to deploy sensors. Nobody cares where or why, but you have to deploy sensors. And we started to do that. We started to deploy flow meters, pressure meters in the DMA, in the inlet of the DMA, and we improved our hydraulic model. And that was the first stage. The second stage in this digital transformation journey was when everyone talked about smart meters. So you have to have smart meters or you are out of market. So we deployed almost, in that time, almost 100,000 smart meters with different technologies from different providers. And we found one, for us, the biggest problem, and was the silo of information. Because in that time, we were managing almost 1 million of sensors in total, and we had more than 10 different software to manage all these sensors. And also one problem that we found was we weren't capable to have or to achieve KPIs to find out how our municipalities were performing, because we have to check 10 different software with different information isolated of the rest of the network and the rest of the software. So it was impossible. So we turned to the market, and the market, there weren't solutions on the market. So we decided to create Xylem Vue powered by Go Agua. In that time was with different name, but at the end it's the same. And we implement a data-centric architecture that allows us to integrate all the information coming from different flow meters, different pressure sensors, different smart meters, different SCADA providers in just one platform. So now in less than 1 minute, we are able to find out what it's taking or what it's happening in our network, and manage all the alarms and all the issues that takes place on the network. So that was the way that came up as a result of Go Agua, or Xylem Vue powered by Go Agua solution. Please, can you jump to the other one? Go ahead. Well, so about non-revenue water reduction, it's important that you must know some figures and numbers. And right now we are managing 12,000 kilometers of pipe, more than 400 municipalities in just one platform. All these figures is related with just one platform. We just using one platform to manage all these municipalities, all these 3,100 DMAs, or almost we are quite close to 1 million smart meters. With just one platform, we are able to aggregate all this information and manage with the hierarchical levels. We are managing all the information and just showing up the information that we want to look for. So related to non-revenue water, this platform allows us to, first of all, prioritize the leak. I mean, we are when we talk about leaks, we could have more than one leak, but with this platform we are able to support our decisions and prioritize the leaks that for us are the most critical ones. And we take into account, for example, the amount of water that we are losing or the cost of reparation. But just for your information, right now we are able to identify a leak, to detect a leak, sorry, in less, or the average period of time, it's 24 hours. With that time, we are aware that we have a leak, and afterwards the decision is us if we want to repair it or not, taking into account different factors, as I was saying. But you are aware that you have a leak there. So once the leak is detected, the next step is locate the leak. And how we work in terms of leaks location? Well, we work in 3 different levels. The first level, it's when we have physical DMAs with, flow meters and pressure levels, but centralizing like between 10,000, let's say 7,000, between 7,000 and 15,000 supply points per DMA. So in that scenario, we are able to locate the leak between 1 and 3 days using different methods. Okay. In the cases or in the municipalities that we implement virtual DMAs, these times goes down until 1-2 hours. And in the most critical pipes, we are using continuous monitoring tools like optic fiber or acoustic loggers or other technology, and let us to locate the leak in less than 1 hour. So once we detect the leak, in less than 1 hour, we locate the leak, and afterwards, it's the decision, the repair decision. Okay, but we pinpoint the leak in the worst scenario in 1 day. Okay, so once the leak is repaired, comes to decision to decide if we want to repair it, taking into account the repair cost, the operational cost, and the strategic cost. But at the end, the tool let you analyze all the information and support your decisions based on data, based on on the parameters that we are having from the field. So in the case that the operator wants to repair the leak, you can create directly from the platform a work order to inform the warehouse and the maintenance team to repair the leak. And when we are talking about industrial customers or key customers or a big area of the municipality, we are also sharing this information with the customer, inform them that due to a leak in the coming 2 hours, 5 hours, or tomorrow between 1 or 3, we are going to cut the water supply because we are going to repair a leak or due to maintenance work or whatever. So we are sharing this information. We are being clear with customers, informing them what is going on the network. And also the most important part for us is the feedback, because once you detect the leak, you locate it and you repair it, this information must be recorded on the system. So right now, the system automatically updates the GIS and the database. So in case that this pipe has several leaks in the coming months or years, you will have all the information to decide if you want to keep repairing leaks or you prefer to replace this pipe because it's too old or the material is not good enough or you have some corrosion there. So, but you have all the information to decide, and everything is possible with Xylem Vue powered by Go Agua, that it's aggregating all the information. So yeah, Aya, please. So can you show all the yeah, much better. No, yeah. So the second use of case or case study that we would like to share with you, it's the digital twin tool that we are working or that we implement in Valencia City. Just for your information, Valencia right now, it's one of the cities in the world that it's performing the water supply services with a real digital twin that we are updating every single minute. So every single minute we run the hydraulic model. Okay, take this information that comes up from the hydraulic model and matching this information from the real data coming from the network. So we are able to identify or to monitorize the network with 96% of accuracy related to flow and 98% related to pressure. So almost 100% of the flow meters and sensor loggers are matching with the data that comes up from the hydraulic model. Right now, we are working in the digital model with 1,100 kilometers of pipes with different diameter from 4 inches to 64 inches. And for me, the most important thing is we are managing 1,700 data per second. So the amount of data that we are receiving from the network, it's a huge amount of data, but we are able to manage all this data and to take advantage for this data. That this is crucial. This is the most important thing. And we also, and this is one of the biggest differentiator, we are also using the data coming from the smart meters for almost 500,000 smart meters. We take all this data and we cross the information with the information coming from the hydraulic model. So our hydraulic model, it's in terms of calibration, it's real close from 100% of accuracy. And for what we are using this hydraulic model? Well, we use it for several things. But among them, we can find operator training, what if a scenario. But one thing that took my attention, took my attention at the beginning was that thanks to this level of accuracy, we are able to identify one of the biggest problems that water utilities has to tackle with, and it's when operators go to field and they change the status of a valve. Let's say one manual valve, they close it, and afterwards they forgot to open it. But for operators, for the operators that are at the control room, the valve is closed. So if the operator don't call you or don't forget that, or don't remember that he forget to close or to open the valve, your system is not working exactly the same that the real system. Your hydraulic model is not matching the real system. So with this tool, we are able to identify these kind of failures in a couple of minutes, because quite quick we identified that the pressure level that we are getting from the hydraulic model doesn't match with the pressure level coming from the network. So we are able to identify this kind of, let's call it, mistakes that operators suffer when they are on field. Also, yeah, as you can see, we use it for maintenance scheduling. So we adapt the water need of the city, and we apply this maintenance work when the city or the area it's not requiring quite a high amount of water. And the last step that we are doing is we are using digital twin for energy saving. We use or we fill up the tanks when the energy is less costly, or when we have the possibility to use solar energy or wind energy or other energy that it's not nuclear or from gas or from carbon. And also we are performing real-time hydraulic model relates on terms of quality of water to identify these shadow areas where the water is stored too much time and the water quality goes down. So we are able to identify these gray areas and monitorize what is going on their network in terms of water quality. Okay, yeah, and also I would like to share with you some pictures of our control room. And from here, as I was saying, we are managing 1,100 kilometers of pipes with different diameters. And yeah, maybe you can see this, or you could see this room from different webinars or from different events, because we feel so proud of this room, because it's it's the jewel of the crown. Well, and yeah, if you jump to the other one, and before we perform the live demo, one of the the 1 million euros question is, I would like to see some KPIs of this digital transformation, and what is the return on investment to transform all your operations from a digital point of view. Well, you have here several features, several numbers, several outcomes, but I would like to share with you the most important ones, that it's, for us, we reduce the non-revenue water more than 80% in average in 400 municipalities. So this is a huge amount of water that we are saving, and we are not just saving water, we also save energy, and this is the most important thing. We are saving water and energy because our efficiency has increased a lot. In Valencia City, we improve our non-revenue water in the last 20 years more than 35%. Just for your information, right now we are really close to 88% well, let's say 12% of non-revenue water in Valencia City, thanks to all this digital transformation journey and the hydraulic twin, the digital twin. And we also reduce our operational, or directly we reduce our operational cost with a reduction of almost 20% of the maintenance cost. And for me, also a key indicator is how the citizens, how the population is perceiving your service. And then the number of complaints has reduced more than 60%, and this is due to now we exactly know what it's taking place on the network, and we could inform users in case that we decide, I don't know, just to share one example with you, but in case that we detect a leak in a downstream of the smart meter, in the let's say in the customer area, we are capable to inform the customer that he's having a leak inside of their house, so they have to do something if they don't want to pay a huge bill. So the perception of the customers in terms of service quality has increased a lot. And yeah, before we jump to the demo, also one important thing is, when we talk about digital transformation, people is quite terrified, yeah, let's call it terrified to lose their job. And in these 20 years, well, yeah, almost 20 years, in Valencia and in these 400 municipalities, nobody, I repeat, nobody has lost their job. So what we are doing is to help these people to offer more value to things that a machine could do. We are we are transforming them to a most value profiles instead to do something that a software could do. So nobody has lost their job in these 20 years. So yeah, from my side, it's everything. We have a Q&A at the end of the session, so I will perform the live demo. I don't know if I could share my screen or.
You try, Pepe. You should be able to.
No, I cannot. The host has to allow me to share my screen.
Okay. In the meantime, if anybody has any questions, do feel free to put them in the chat.
Please inform me when I can share my screen.
Yeah, why will we?
Oh yeah, the link to share screen is open. So
okay, I will stop. I will stop and let Pepe take over.
Okay.
You have about 5 minutes, Pepe.
Okay. Let me see if I can. Can you see my screen?
Yes, we can.
Yeah, perfect. So, well, first of all, as you can see, we access to the Xylem Vue powered by Go Agua platform through an internet browser like Chrome, Edge, Firefox. So you just need your username and password, and you have access to this. Sorry, to this portal we call Xylem Vue portal. So there you have access to all these platforms. We create that because at the end of the day, it's not nice, let's call it in that way, that you have to have several marks on your browser to remember different solutions, and you have different username and different passwords. So we centralize, or we aggregate all the platforms in just one site. So within the leak detection module, okay, it's the module for monitoring the drinking water distribution network and reducing the water losses of non-revenue water, as you see on the screen. Okay. Well, I'm gonna be quite fast because we have 5 minutes remaining. So all the Xylem Vue solutions has the same look and feel. So once you get inside, you have some KPIs at the top part of the screen, some settings options here to set alarm, to set sensors, to set notifications. You can customize the people that get an alarm in case that you have a non-revenue water value, and so on. Let me reduce a little bit the zoom to have a better look. Okay, as I was saying, some KPIs, and we also break down the map with these boundary areas that is related to the DMAs of the city. As a disclaimer, I have to say that for confidentiality reasons, we are not allowed to show real numbers from the municipalities. So we change the numbers. So in case that you see weird things, it's because the software sometimes make crazy things in terms to to keep the confidentiality. So don't be worried about that. Okay. So for us, the map is also an important tool to reduce the non-revenue water. So you can zoom in, zoom out, and you also can activate and deactivate different layers. So you can activate the GIS layer and activate or deactivate the DMA. So in just this map, we are centralizing the information from the DMAs, from the non-revenue water, from the pressure system, and the GIS. Okay, everything on the map. And as I was saying, we are managing all these 400 municipalities with the hierarchical level. In that case, we are working with the city of Gandia in the east coast of Spain. But in case that we were using a real environment, we will see here all the municipalities that we have access to. So in that case, I'm going to work with the city of Gandia, as I was saying, and here we can see the different DMAs that we have on the screen. So in case that we choose one, on the main dashboard, all the information would change to show the most important KPIs of this DMA. So right now we have one alarm in this DMA, some details of the network, the user types, and the water distribution efficiency related to this DMA. The map centralized information of this DMA, and we also keep having the possibility to activate or deactivate the network, the sensors, and so on. So once we have the information on the screen, we have here some options to get more value of the information. So we can see the water balance of this. In that case, we are going just to focus on this DMA. Of course, we can do it for all the city, an aggregate of all the cities that we are managing. Okay. As I was saying here, more details. In this DMA, we have 234 meters. Okay, and yeah, 231 of them are equipped with with smart meters. Okay, and 3 of them is not equipped with smart meter technology. So here we can see the water balance itself. Okay, in terms of hourly, daily, or monthly. Okay, comparing other years, other months, other days, or the hour analyzed. So here we also have the possibility to sorry, because I'm watching the screen, that one, to amplify the information and zoom in the part that we want to take a look. And in case that we are not able to see all the information, we can activate or deactivate the different layers. So if we just focus on water supply and let's deactivate the other ones, water supply and non-revenue water, we see that the bill water and the water supply has a difference for the reason we trigger an alarm that the non-revenue water, we have to focus on the non-revenue water in that case because something it's taking place. Okay, and here we see some aggregate information. We also can have a look to the service connections to have from one side the hydraulic early water balance and also a water consumption heat map with different level of granularity. So in case that we want to have you know, a more detailed information of what is going on, we can increase the level of granularity or decrease. And it works, for example, if we change to another DMA, as you can see here, all the information would change to show exactly what is going on this DMA. And not just we work with visual information, we also work with you know, numeric information. So you can you have here all the supply points organized by the volume of water that the supplying points has consumed. So we always can have a better understanding, okay, showing the details of the past consumption, the consumption forecast. And it's important here, you can see the grays one, you know, this is because these supply points, we have a lack of information due to whatever network issues or other issues, and the system has the power enough to show you or to fill the gaps, to show you how the, you know, how the consumption forecast must work. Okay, also we can identify the supply points on the map and the consumer type. You know, if it's an industry, an office, and commercial, hospitality, so and the kind of alarms. And also, just to show you the flow matrix, the flow matrix is related all the information that we got from the loggers around data. So we here in that tools, we are not applying algorithms. So we are showing the information in a raw way to make the technicians, you know, to make possible to work with the data without bit-read. You know, everything related to flow and to pressure. And yeah, before we finish, I would like to show you the alarms. Well, we can change to the older city of Gandia. Okay, to have, you can see how quick we can have all the alarms that took place on the city of Gandia. And in case that, you know, we want to see the details of the alarm, let's say, okay, this is a non-revenue water because we have an excess of almost 300 liters above the limit. But for me, the most important thing, as I was saying, is here you can directly generate a work order. So quite quick, you can create the alarm, and if I could press accept, you know, the team will get this alarm to go to the field and detect and repair the leak. So without, you know, changing between tools and so on, we connect this tool with a work order solution. So it's quite quick to create this work order. So this is the solution, and just we finished. I would like to show you the service operations center because it's the biggest aggregator in terms of fighting against non-revenue water, because there we are centralizing all the information coming from different cities and coming from different solutions in just one platform, and we aggregate all the alarms, you know, in a map view or in a table view. but we are getting here data from smart meters, from non-revenue water, from SCADA, from work orders, for the billing process, so everything in just one platform. Yeah, and that's all from my side. Please, in case that for sure you will have several questions, so feel free to ask Ian and me whatever you want to find out, and yeah, we will do our best.
Okay, thanks, Pepe. We have two questions. One from James first. For leak detection, how is it done? Is it done by sort of survey, so traditional ground microphones and correlators, I'm assuming, or through permanent logging?
Well, in most cases, we work with permanent logging. Okay, we log the pressure and flow for sure. And okay, you mean leak detection? Sorry, my fault. Okay, it's in the critical pipes, you know, in the high diameter pipes, we work with permanent logging. But when in the distribution pipes, we work with survey method. We use different methods like, yeah, acoustic loggers in some of them. In other, we use correlators or geophones or other technologies to identify leaks. But yeah, we also work with, in cases that we have hydraulic model available and smart meters, we are, you know, we move a step forward and we are doing some proof of concepts to validate if or to implement the technology to find leaks using the hydraulic model. But this is something that we're still working on it, but it would be the next step.
Okay, and the next question is from Chris. How is the pressure data collected? Is it from AMI platform or direct cellular, etc.? And how often is pressure data recorded?
Well, pressure, normally we work with 3G, 4G. You know, we have these pressure and flow sensors. So we send information through 3G, 4G loggers or regular loggers. But there are some providers that has this pressure sensor on the smart meters, but this is not our case. We use the smart meters, you know, to measure water, and we use the pressure sensors to measure pressure. So we try not to mix at least on this stage. We try not to mix the way that we got information. So yeah, I would say pressure sensor, we use the cellular network.
Okay. The next question is from Andrew. What is the typical return on investment based upon all of the DMAs that you've done, all the municipalities?
This is the $1 million question. I mean, everyone, you know, when we talk about non-revenue water, everyone wants to find out the return on investment. Well, it's not easy to say, because it's not just to identify a leak. You also have to repair it. But for us, implement and also you have to take into account your point. You know, it's not the same if you are 40% of non-revenue water or 60% of non-revenue water. So you have to take several things into account. But we can, or you know, as for your information, we can reduce, or the experience that we have, we can reduce almost 20% of non-revenue water in a short period of time. I mean, we are talking about years, okay, but in a short period of time. But if you want to have a real, you know, return on investment scenario, you also have to measure the energy that you are saving, because you don't need to pump the same amount of water to the network, because right now your efficiency has gone up.
So that ends the question. So I just want to thank everybody for joining us today. I want to thank Stuart, IWA, for hosting us. With that, Pepe and I say thank you very much, and
thank
hopefully
you so much.
We'll see you all again on the next IWA presentation. Thank you.
Okay, bye.